Hello again. This is Math 0482, and this contribution is being recorded on September the 7th, and the title of this lecture is Solving Absolute Value Equations. Previously, we learned that the absolute value of a number describes its distance from 0. So on a number line, if we say the absolute value of 5, and we write that with a vertical bar, 5, and another vertical bar is equal to 5, and we say the absolute value of 5 is equal to 5, or we could also say the absolute value, a vertical bar minus 5, new vertical bar, is equal to 5, because both of these on a number line are 5 units from 0. Now we're going to use this idea of distance from 0 to solve absolute value equations and inequalities. The inequalities will be in a separate video. For now, absolute value equations. Let's start with a simple example. Solve the absolute value of x is equal to 3. Now, since the equation contains an absolute value, when we ask you to solve, the absolute value of x equals 3 means find the number or numbers whose distance from 0 is 3. And by inspection, if you think about the number line, that means you start at 0 and you could either go to 3 or minus 3. So those numbers are 3 and minus 3, and each of them is 3 units from 0. So the solution set has two answers. It is minus 3 and 3. We're going to use the similar procedure for solving an absolute value equation. And now we're going to be talking about the k, the constant that I talk about, is bigger than 0. So if p represents an expression, and the expression could be x, it could be 3a plus 2, it could be 1/4 t minus 9, and so on. That's what p is. And k is a positive real number. And we're talking now about solving a problem that says the absolute value of p is equal to k. Our approach is we will rewrite the absolute value equation as a compound equation. And we will say if the absolute value of p equal k, we will say that p equal k, or, and that's the word or, p equal minus k, and solve for the variable in each case. Let's do a couple of examples of this. Let's start with the first example where I say the absolute value of m plus 1 equal 5. Solving m plus 1 equal 5 means find the number or numbers that can be substituted for m so that the quantity m plus 1 is 5 units from 0. m plus 1 will be 5 units from 0 if m plus 1 is equal to 5, or if m plus 1 is equal to minus 5, since both 5 and minus 5 are 5 units from 0. Therefore, we can solve the equation this way. Again, we write m plus 1, the absolute value of m plus 1 equal 5, and that means m plus 1 could be 5, in which case m is 4, or m plus 1 could equal minus 5, in which case m is minus 6. So the solution set for this problem is -6 and 4. M could be -6 or m could be 4. Let's do a second example, perhaps a little more complicated example. The absolute value of 3/2 times t plus 7 plus 5 equals 6. Now before we rewrite this equation as a compound equation, we must isolate the absolute value. That means get the absolute value on a side by itself. And so you see, we are going to have to subtract 5 from both sides. So we started with the absolute value of 3/2 t plus 7, end of absolute value, plus 5 equals 6. So when we subtract 5 from each side, we'll get the absolute value of 3/2 t plus 7, end of absolute value, is equal to 1. Now that means that we have two sets of equations that we must solve. And so we will solve 3 halves t plus 7 equal 1, or 3 halves t plus 7 equal minus 1. And we have to solve each of these. So if we are solving 3 halves t plus 7 equal 1, that will give us 3 halves t equal minus 6. And then we will have to divide both sides by 3 halves, and we will get t is equal to negative 4. Or we could have had 3 halves t plus 7 equal minus 1, and then 3 halves t is equal to minus 8. In this case, t would be minus 16 over 3. So there are two answers for this problem. T could be minus 4, or t could be minus 16 over 3. Now, here is a problem for you to try. And so the problem I'm asking you to try here in this video is the absolute value of 1/4 n minus 3, end of absolute value, plus 2 equal 5. That is a vertical bar, 1/4 n minus 3, end of vertical bar, plus 2 equal 5. I ask you to pause the video and try to solve this, and we'll come back and compare your answers. So please pause the video. Let's see how you did. Your answer to this you try should have been that n could be 1 or n could be 7. Now, before we go on to the next example, be sure that you think about the value of k whenever you're solving an equation that looks like the absolute value of ax plus b, end of the absolute value, equal k. Because let's talk about this example. Solve the absolute value of 4y minus 11 equal minus 9. Well, this equation says that the absolute value of 4y minus 11 equals negative 9. Can an absolute value ever be negative? No. That means this equation has no solution, and the solution set is the null set. We now move on to solving an equation that has absolute values on both sides. We're going to be solving an equation of the form absolute value of ax plus b is equal to the absolute value of cx plus d. And this is another type of absolute value equation that, again, is going to involve two absolute values. So the procedure for solving this is, if p and q are expressions, then to solve the absolute value of p equal the absolute value of q, we rewrite the absolute value equation as a compound equation, either p equal q or p equal minus q, and solve for the variable. Let's work through an example. In this one, I'm asking you to solve the absolute value of 2w minus 3 is equal to the absolute value of w plus 9. Well, so this equation is going to be true when the quantities inside the absolute values are the same or when they're negatives of each other. And so if the quantities are the same, we would write 2w minus 3 equal w plus 9. And we solve that and get w equals 12. Or if the quantities are negative of each other, we would write 2w minus 3 is equal to minus parentheses w plus 9. Again, we're saying that they're negatives of each other, so it's 2w minus 3 is equal to negative the whole of w plus 9 in parentheses, in which case we solve it and we get w is equal to minus 2. So the solution set here is minus 2 and 12. And it is important that you must put parentheses around the expression with a negative, as in this problem, negative parentheses w plus 9 into parentheses. Here's one for you to try to solve. Solve the absolute value of c plus 7 is equal to the absolute value of 3c minus 1. So pause the video and try to solve the problem. And then after you've solved the problem, come back and listen to the video to see how you did. So pause the video. Let's see how you did. And the answer to this you try 4 is going to be, you should have gotten negative 3/2 and 4. In closing, remember, time is precious. Each day must count. Do the math, it will make you strong. More later in the next video.